video I will show you how to add support for the LCD in your project and also how to use the resistive touch controller. So let's get started. So we will be starting with the example which uses USB communication, and we will use the communication to turn on the display. So first let's add the necessary ASF wizard configuration. So we will add the SPI driver and the API of the master. Okay. In here we have some drivers for the controllers, like the ILI 93XX, but those add-ons, they just don't work correctly. There is much to do with them to make them work as intended. So instead of adding them, let's firstly build the solution. So we will say the ASF wizard add-ons. So instead of this, we will first close the solution, and now we will add an example project which uses the driver which we have in our device, I mean the display. So let's search for the driver, which is ILI 9341, and in here we have this example. The board is different than ours, and let's create this solution as a new one. Okay, so now we have the main function for this example, and we will copy the defined variables from here and the interior of the main, with exception for those two functions, and we will make out of this main a new function to turn on the display. So we can just for now on copy everything. Now let's close this example, open our own project. Okay, and now let's copy from our main and let's call it display start. And let's set the type to void. We don't need anything from this function. Okay, let's erase this. Okay, so this function we will trigger in the function of our main loop, and we will listen for sending 1 in ASCII in here. Okay, now the thing is, we need to configure the SPI. So let's start with enabling all the GPIOs. Like so. And now let's add the functions we need to implement from the example which we generated. So let's go to config and let's add existing item. Let's go to the folder of our example and let's add this file, the config. First of all, in the config file we will change a few things, like add a define, like SPI LCD, and we will copy this into this if. So doing so, we will enable this define, and we have to say it uses the SPI 0 instance. This is the default speed for the LCD, and those we can declare in here, but we can leave it as it is for now on. And now let's add a few more files into common services, and in services let's add a folder and let's name it display. And in here we will copy 3 files which we have to add from the example. So going back, ASF, common, components, display, and those 3 files. Let's add them. And now we have to change a few things. Let's go to the C file first. And now we see the function to select the chip, so the CS pin of the LCD. So instead of using the IO port, we will use our all-known PIO driver. So let's copy it. And first, let's add in the H file the include for this driver. Okay. Okay, and now for the CS pin, I will use CS display, so D6, and that means PC24 pin. Okay, now let's copy it into the deselect function. And let's set it to high. Next is the DC pin, which is data command pin. And for this pin, I use D8. So it is PC22. and the data select is also PC22, and we have to set it high. Okay, now the reset pin, which is in this function. And now for the reset pin, I use D9, so it is PC21. And here set it to low. And also we need to go to the H file, and at the beginning we got a function for setting the backlight right here. So for the backlight I use D11, so it is PD7 pin. And now to turn it off, we set it to low. Okay, now let's add the H file to our main. So we need to right click on it and copy full path. Okay, I also added string.h and stdio to use strlen and sprint functions. Okay, now let's see if we got everything set up. Also, it would be nice to set the pins for chip select of the LCD and also the touch controller to high before beginning any operations on it. And also we will configure the pin for the interrupts from the touch controller as an input, like so. It is PC23, and that is D7. And the chip select for the touch controller, it is D12, which is PD8. Okay. Now let's try to build a solution. Okay, so no errors. Now let's flash the software to the board. So now I'm resetting it. Okay. In both I select the port, go to our application. Okay, now let's reset the port. Okay, open the terminal, and now we will send 1 to it. Okay, and sending 1 now. And as you can see, this is the example from the generated project. So we can also add touch control to it. So let's just do this. So now going back to our main function, in here I got an example code for the touch control, and it will be working like if we receive an interrupt on the pin, we will read the value for the touch, so X and Y axis coordinates, and we will draw a few pixels in the loop of the example. So let's declare a few global variables for X and Y coordinates. Maybe let's just cut and paste on top of it, so we don't get any errors that we didn't define them. Okay. And now we need the function for reading a GPIO pin. So let's find this function in the PIO file. So let's just go to the H file. And as we remember from the first video, we got some definitions in here for setting the input, and in here the function for reading the GPIO. So let's copy it. Let's go back to our main file and to the main loop of the example. So this is the loop which prints the stuff non-stop on the screen. So in here we will add a if statement, and we will check for the low values of the pin. So let's add it. So now let's see what our pin for interrupt is. So it is PC23. So let's change it up. So whenever this pin is low, then we will trigger our function to read the coordinates. And also we need to make a prototype for this function to get access to it, so we don't get any errors, because it's lower in the code than the function we will use it in. Okay, so let's make something like this. So in this function, we will read the coordinates and save them to our global variables, so X glob and Y glob. And now let's draw a few pixels. Okay, so now the X will be X glob, and Y also glob. Fine. And we will draw a rectangle 10 by 10. And now we will have to set a color for it. So let's go to definition for this background color, and we see the function for generating a color. So the first, so blue, green, red. So let's add a color to our rectangle. Let's paste it and let's say it will be something near to white. Okay. Now let's build a solution. Okay. So now let's erase the board and flash the software. Okay. So now let's reset the board. Let's get in here. And again we will send 1. Okay, so sending 1 now. Okay, let's turn it on. So we are now in the main loop. So let's try to draw something. Okay, so the drawing works. Now let's talk about a few options we got to set for the touch control. So in this function, to read the coordinates, I use right here chip select. I send data, which is a command to read the raw values for the x-axis, and I read 2 bytes. That's actually a little mistake I made, because the first one, red, is actually the x-axis. But that's right here. Oh, sorry, it's right here, corrected somewhere. Yes, in here. So the y-axis is actually red first, in here, then the x-axis, and we read 2 bytes. So the 2 bytes we read, we have to left shift to the first the high value, and then add the lower value, and we have as we got this, shifted to the right 4 times. And now let's say Y. In the datasheet for the controller of the touch, if we go to the interface, we can see this is the byte we write. So this is always 1. This is the configuration for the input for the controller to read. This is the mode in which the controller puts out the data. And this is the selection for the input selection. And those pins are used to turn on or not turn on, for example, internal reference or the continuous mode of reading the coordinates and not use the interrupts. So let's take a look at what we can read from it. So going up, we got 2 tables. And now if we select the mode bit to 0, we will use those inputs. So if we want to read the Y position, we will select those bits just like so, and the X will be this configuration. But if we select it to 1 instead, we have to select it just like in this table. So Y position also this, and X position also this. Basically the same. We also got some other configuration we can use, but we will use the default from this. And now let's go back to the data we receive. So if we got it in the 12-bit mode, the communication looks like this. This is our command, send, and now we read 1 byte, and this is just this part of the message, and that is the second byte we read. So the most to the right, the least significant bits are just 0, so we just have to ignore them. So that's why after we got this value into our variable, we shift it to the right by 4. So thanks for watching, see you in the next one.